the place where we call the sort method. This is the line 36. So the sort method is assuming that whatever elements in this array, they are all comparable type. Okay, it's actually casting it into a comparable and then calling the compare to method. Okay, fine. So the significance of making it implement comparable. Okay, fine. So let's revert back. Okay, if we change it, restore back and say it is implementing comparable, then okay, if we run, yeah, it's running. Okay, so this is a comparable interface. Okay, it is used for ordering, for defining the order of the natural order of comparing objects. For account, it is based on account number. Okay, fine. But account is not the only, account number is not the only attribute based on which you may be ordering them. You may like to order them by maybe balance, or you want to order them by the names. Okay, and so if you want to order them by any other criteria, right, we have a different interface to implement, and it's not the account which will have to implement that interface. Okay, but we want I think what I'll do is I'll try to show you some of the part of the okay, here is the for the Java library, the entire documentation is available here. Okay, fine. So from Java 9 onwards, there are modules. So things have been divided into modules. So you will have to first select, you want to look at documentation for which module, right? So here, most of the things which we will look at from the Java API are going to be from the java.base module. Okay, so we select the java.base module. Okay, so within the java.base module, the documentation which we are looking for, we want to look at that comparable interface. Okay, so that appears in the java.lang package. Fine. So within the java.lang package, fine, related packages, you can skip that. Okay. Now you want to look at the interfaces only, right? Maybe. Right? So you just say interfaces, and here you can see there is an interface called comparable of t. So you select this comparable of t, and this one says yes, we have the okay. See, in each of those documentations, what you will also find is that which are the classes, which are the interfaces which are extending from this interface called comparable. So all known sub-interfaces means all those interfaces which extend from comparable. And other one is saying all known implementing classes, which classes implement this particular interfaces. Okay, so you will find that all the various the classes under the wrapper, all the wrapper classes will be found here. I'm not, it's a huge list, so I'm not individually pointing out where it is. Okay, string class and most commonly used classes, they will be implementing the comparable, but here is the documentation for comparable. This interface imposes a total ordering on the objects of each class that implements it. This ordering is referred to as the class's natural ordering, and the classes compared to method is referred to as its natural comparison method. Okay, so this is defining the natural ordering for objects of a class. So yeah, various information is there. Fine. So here it says, okay, for the relation that defines the natural ordering on a given class C is x comma phi such that x dot compared to y is less than equal to 0. Okay. Okay. So here is the compare to method and the documentation for compare to method. Right? And here it documents returns, right? What does it return? Okay, a negative integer, 0, or a positive integer as this object is less than equal to or greater than the specified object. Okay, so that's where the documentation is. Okay, fine. Okay, so this is one thing which we have seen, which is nothing but your comparable interface. You would like to have a look at the arrays class, maybe? Okay, let's check the arrays class then. So for looking at arrays class, let's go back to the package list. In the package list, we have the java.util package. And in the java.util package, okay, fine. We are looking at classes here. So this is a class called arrays. Let's check that class called arrays. Okay. Fine. So this class contains various methods for manipulating arrays, okay, such as sorting, searching, and find various things which can be done on a array. Okay. So let's directly jump to the methods which we are interested in. I think two of the methods we have seen here. One is the method called sort, other is the method called toString. Okay, but yeah, you can go through this documentation and see what all different kinds of methods are available, utility methods available for arrays. Okay. Yeah. Here is the sort method, right? So sort method for sorting byte array, primitive type sort methods are there. Okay, and then we find a sort method which says you can give me an object array. Okay, this one says object array, but here's the generic method. Okay, and this line, that's where you find a generic method. Okay, okay, yeah. So this is the one actually which we have used currently. Sorts a specified array of objects into ascending order according to the natural ordering of its elements. So this is the sort method which we have used here. So give it an array and that will get sorted. But provided all the methods are methods, okay. See, it says sorts a specified array of objects into ascending order according to the natural ordering of its elements. All elements in the array must implement the comparable interface. Fine, they must implement the comparable interface. Fine, so elements must be implementing the comparable interface. interface. That was the requirement which we had. Okay, fine. So we see sorting according to account number. But another thing, now let me come to another interface in this same package, java.util package. So we have an interface in the java.util package. Let's come. So go back to the package list. Yeah, members of the package rather. Okay, so here are the classes and interfaces in the package. Let's see this classes and interfaces. And we are now interested in interface available in this package. Okay, now the next interface which we will look at here is the interface called comparator. Okay, when we go to this interface in the documentation, you find another thing which says it's a function interface. Okay. So we have mention of something called functional interface. So what is a function interface? Let's look at that aspect first. Okay, and then we'll come back to what is how to use the comparable for ordering objects. Okay. So one thing what you should know at this moment is that there are two interfaces. One is an interface called comparable, another is the interface called comparator. So if you want to make comparison of objects of a class, there are two interfaces which are involved. Okay, comparable is used for defining only the natural ordering. Okay. Okay. So any kind of comparison logic can be specified by making use of comparator. Whereas comparable will be there for natural ordering. So anything which has a natural ordering. When yesterday I was giving example that if someone says color, then no, color cannot be said to be comparable because color doesn't have its own natural ordering. And someone could say, okay, I would like to order color based on their brightness, maybe, okay, or any other criteria could be there, but they don't have a natural ordering. There's nothing which says, okay, this is less or greater or how to define. It's not obvious. It is based on some other criteria. It's not a natural ordering. So if that is the case, right, your class fine, a class will not implement comparable. So not all classes will be comparable. So if you are making a class comparable, it means you are saying, oh, they have a natural order. There is some order for them, which is very natural for them. Okay. And of course, any kind of class, objects of any kind of a class may different ordering logic, right? For example, in account class, someone says, oh, I want them to be ordered by the names, or I want them to be ordered by balances. And, it could be any kind of a criteria which we may look at for the purpose of ordering. So to define any other kind of ordering, we make use of what is known as, what is the interface called comparator. Okay, fine. We'll come back to comparator. Okay, but before that, to make use of comparator much easier, okay, we may have to look at a concept which has come from Java 8. Okay, so I'm just picking up a new concept here. Okay, the concept of what is a so we have something called a functional interface from Java 8 onwards. Yeah. Right. See, now what we know about interfaces, okay, from what we know about interfaces, interfaces can have what kind of methods? Okay, fine, it can have abstract methods, okay, three type of methods, right? What are those three things? Abstract, default, and static. Okay, so a method in interface is either one of the three, right? Abstract is the default, right? Okay, not this default, I mean. Okay, so by default it is so if you don't mention anything, this is what is taken as a default. Okay, I'll just put it here. Yeah. Okay, so if you don't mention anything, it will be considered to be abstract method. Okay, fine. Interfaces have three types of methods. This is from Java 8. Okay, fine. Now, what is a function interface? A function interface is an interface with any interface with only one abstract method. If there is only one abstract method, you may have any number of default and static method, doesn't matter. But as far as abstract method is concerned, if there's only one abstract method in an interface, then such an interface is called a function interface. Okay, I think it's already mentioned. A interface with single abstract method. Okay. Okay. So let's look at an example of a function interface. Okay. So yeah. So we have this interface called comparator in the java.util package. Okay. Yeah, there's one small rule I'll have to mention here. Okay, over just not looking at this it from this point of view that it's only a single abstract method, with a slight modification which I'll have to mention here. Single abstract method, ignoring, I'll have to say ignoring the public methods of the object class. You know the methods of the object class? We have those 11 methods of the object class, out of which 2 were protected, but other 9 were public, right? So, when you define an interface, see, for example, see one thing which you may find slightly awkward here, okay, and it is anyway, is something like this. You're defining a public interface, let's say. See, if I'm defining an interface, I'm taking example of interface, but it could as well be a class, okay. For example, I'm writing a public and abstract class, right? And in this, oh, it may have abstract, it is allowed to have abstract method. So I say, oh, I have got a public and abstract method which returns, it returns string, name of the method is toString. Yeah, I declare it as abstract. But if you look at this method, what is this method? This is the method which is the method of object class. Right? What it is implying here is that you are overriding a method which was not an abstract method to become abstract. Yeah, I may even write like this. Okay, even this is going to compile. Okay, want to check this out? Okay, I'll just start JShell and let's see if that code can compile. So we have the public class called public and abstract class we wanted. And it says, why override? Because it's a method of the object class. So I'm saying our class extends from object, and therefore I can say, okay, public, and I'm making the method abstract. So a non-abstract method may be overridden to become abstract. That is also valid. Okay, it's an abstract method. Put a semicolon, and maybe I just end my class definition here, and that is fine. That's perfectly fine. Okay. Here, this is something which has been allowed. Fine. Fine. The point I'm trying to make is a non-abstract method in the superclass is being declared to be abstract in a subclass. Okay, so this is something which is going to be valid. Right? Exactly on similar line, just like what you can do for a class, you can do with an interface. When interfaces, they don't say that they extend from any type, but we understand that object class is the super type of the fine. Object class is a super type for all interfaces also, right? For any reference type. Okay. So if I put it like this, even this is valid, right? That is, object class toString method is not abstract, but a subtype is saying, I want to make it abstract. So this is something which has been allowed. Okay. So the point here is related to the functional interface, the definition of functional interfaces. When you say how many abstract methods are there in this sum interface, so for the purpose of saying that yes, a class with only one abstract method, so from that point of view, no, this does not have an abstract method. some interface here does not have an abstract method because I have to ignore any public method of the object class. So this toString is nothing but a method of the object class, so don't count this. This some interface has zero abstract methods because toString here is the abstract method of the object class, it's a public method of the object class, and therefore I shouldn't be counting it here. Okay, fine. Just like to know whether a particular method is an overriding method or not, we put @override annotation. On similar lines, we also have another annotation which is available for interfaces. You can say @functional interface. Okay. Right. So you can say @function interface and then put the interface definition, and it should give a compilation error if it is not a function interface. So this doesn't qualify as a function interface. No abstract method found in interface sum interface. Oh, we have an abstract method, but that's not being counted as abstract method because it's the method of the public method of the object class. Okay, so I put this ignoring the, so this is that additional clause I put. Okay, ignoring the public methods of the object class. So if someone is overriding and making it abstract, don't count that as an abstract method. So this thing is available for class as well as for, and overriding method to become a concrete method. Fine, a method which has an implementation becomes abstract in a subclass. That's also allowed. Okay, that's one thing. It's slightly awkward, right? But yes, it is. But that's how it is. Okay. So now let's go back and look at the documentation for comparator interface. Fine. So comparator interface, yes, it is saying it is abstract. If you look at the methods, see why I was showing this is, if you look at the methods, especially what are the abstract methods it has? Well, it says there are two abstract methods. Fine. There are two abstract methods. One is a method compare. Fine. That is the main abstract method. But other method is the equals method. Now you can see this. What is this equals method? Okay. Fine. What is the equals method? It's a method of the, fine, this is nothing but our method of the public method of the object class, and therefore we don't count this, and that is the reason where this qualifies as a functional interface. You can see this is being mentioned as a functional interface. Yeah, it says this is a functional interface, fine, and therefore can be used as assignment target for a Lambda expression. Yes, this is what is the important key thing, the new thing which was introduced in Java 8. Okay, fine. There is a concept of a Lambda expression in Java 8. Okay, fine. So let me now introduce what is a, so an interface, one thing is an interface with single abstract method, fine, ignoring any any public method of the object class is a function interface. Okay, so this is, comparator is an example of a function interface. Okay. Reason being, oh, there are two abstract methods. No, only one abstract method. Though the method list shows there are two abstract methods, but we don't count the one which is the method of the object class. The second method is not to be counted as abstract here. And definition of a function interface. Any questions for what is a function interface? Want to repeat any concept? No one is speaking anything. I don't know. Is this understood or not? The definition of a function interface. Okay, let me try explaining here. See, if it's an interface, right? I'll just put it as a block here. If it's an interface, let's consider this is an interface. What can go in an interface? Okay. Only things which are possible in interface as a members. What are the things? Static constants. When you understand what I mean by saying static constants, that is public, static, and final. Okay, variables can only be public, static, final. Okay, it can have abstract methods. When only members for an interface can be static constants, abstract methods. This is up to prior to Java 8. From Java 8 onwards, we even have default methods and static methods. Okay, and this is what is a interface, right? The what can go in an interface, or these are the only things which can be there in an interface, and nothing else. Okay, another concept put here is all members of an interface are always public. You may not declare them public, but they will always be public. Okay, only one more thing which has started from Java 9 onwards. Okay, from Java 9 onwards, for a default method or even for a static method, this is from Java 9, they are allowed to, you are allowed to have default methods which is declared to be private. Private has been allowed for default as well as for the static methods. Okay. So you are free to have some static method which is private or some default method which is private. The idea here about private, this is from Java 9. Okay, that is, this happens from Java 9. Okay, fine. The idea being, yes, private methods. Why do we have private methods? The reason for a private method, if a method is private, we understand it's going to be used only within this type itself, right? So if there is a private method in a class, that method is usable only within that class. So other methods might be using it. So the idea of a default method being private or a static method being private is they will be used, if it's a default method which is private, it would be usable from other default methods in this interface. Similarly, a static method which is default, a static method which is private is going to be usable from other default and static methods of the interface. Okay, so that's one reason they said, okay, you want to have private methods, you can have. Okay, so from Java 9, Default and static methods can be private. Okay, but otherwise all members, if you don't mention anything, they would be considered to be public only. So if I don't say private, and you can't anytime say protected, you can leave it blank, so don't mention a access specifier. Okay, then it is nothing but public. Members are public here in interface. Okay, next. Yeah. Okay, so yeah, now what is a function interface? Interface where you may have all these things, right? But as far as abstract methods is concerned, okay, from abstract methods point of view, there's only, so function interface means only one abstract method. Okay, fine. So static method, fine. Abstract, one abstract method is a function interface. Okay, and use of the function interface. Function interface, it mentioned, is nothing but it can be the target of an assignment. This type is a target of an assignment of a lambda expression. So let's see what is a lambda expression. Okay, let's try to understand what is a lambda expression. I'll show you the syntax for a lambda expression first. Okay, this is first thing. So syntax for a lambda expression. Okay, so lambda expression is written just like we write a function. Okay, it is to be written like a function, but we don't give a name to the function. And we don't give the name to a function here, or when we are writing a lambda expression. Okay, so what does a function do? Okay, you can look at how do we look at a function? Function can be looked at as some kind of a box here. Okay, fine, which is taking input parameters. So there are inputs coming to a function. Okay, the parameters which are received are inputs to the function. The function does its own processing work. Okay, and would return a value, or maybe it doesn't return a value, but fine, if this is nothing but your return type, right? This is your return type. Return type word means not returning a value. Parameter list can be blank, not taking any inputs, or it can have any number of elements here. So it has input and it has an output, and in between, yes, it's doing the processing. So that's your fine. These are nothing but that's the way you write a method, right? So when you write a method, yes, in a method, what is representing the input? The parameter list. So a lambda expression uses a parameter list. Someone can say, okay, I have a lambda expression. So this is, someone says I have int a comma int b. So I'm saying I'm defining a method. Okay, I'm defining a function which takes two integers as input. Okay, and then so input is what is the declaration part first, and then you write a lambda operator. So you just put it like this. This is a lambda operator followed by either a single statement or a block of statements. So maybe I write a whole block of statements. So I'll say, okay, let me have a block here, and in the block I'll write a number of statements, and maybe the last thing I might be doing is I will be saying, oh, I want to return something here. Okay, maybe what it is returning is a int value. So this is nothing but a simple lambda expression. This is how a lambda expression looks like. It has three parts in it. First part is the input declaration. What are the input parameters? Second part is the lambda operator, and the third part is your implementation. Okay, this is your implementation part, third part. Okay, so fine, syntactically it is like this. Okay, but you can't just put a lambda expression because it what is a lambda expression does not represent a type. On its own, it doesn't represent any type. You can't determine what is the type for the lambda expression unless it is put in some context. How you are using, where you are using this defines what this lambda expression is for. Okay, for example, this lambda expression which I have written, okay, I could be writing like this. If I'm using it someplace, if I write like this, so on its own it has no meaning. Okay, but if I say, oh, there is one particular functional interface. Now see, we use it in context of a function interface only, lambda expression. So there is one function interface called int binary operator. Okay, there is a functional interface called int binary operator. It has methods, right? It can have, we know function interface has methods, but it has only one abstract method. So now I'm putting, what is that one single abstract method of the int binary operator. Okay, so this function interface called int binary operator has one public method which is abstract. So this is, here it has a public method which is abstract. Method's return type is int. Name of the method is apply as int, and it takes two parameters. It says, oh, I'll take an integer a and int b as a parameter. So this is the abstract method we have. Right? There may be default methods in the int binary operator, right? Maybe it has inherited some of the things, but yes, this is what the method looks like. Okay, so it has this one abstract method. The functional interface is a one which has only one abstract method. So here is one functional interface with an abstract method. Okay, so now that above lambda expression which I have given on the top here, okay, that can be used here in this manner. You could use it like this. So, now this is what is the definition for int binary operator. Okay, the int binary operator is an interface with one abstract method. It becomes a function interface because only one abstract method is there. Okay. Now how we use it is like this. I can say int binary operator. Maybe I want just to call it OP1 or something. A variable name. It's a data type. Interface is a data type. I can have a variable of the type. But here it can be the target of assignment of a lambda expression. On the right hand side, I can put that same lambda expression which I mentioned on top. I can say int a, int b, okay, a lambda operator, and in braces I'm putting, maybe I just simply write only single statement, but I'm putting it in the, so I'm saying return a plus b. I'm just keeping it a simple one. Okay, so this entire thing, so on the right hand side after the equal to sign, this entire thing is a lambda expression, and I may put a semicolon like this here. This is to finish the assignment. Okay, fine. So a lambda expression can be something like this. Okay, fine. So if you identify that a particular interface is a function interface, you are free to have a lambda expression like this. But what does this execution of this statement actually mean here? So what happens when someone executes this statement? Okay, let's try to understand that. Okay, does this statement result in addition of two numbers a and b? This statement, okay, this statement here, fine, which I have written as a int binary operator op1 equals, and I have written this statement. Do you think it results in execution of a plus b, or execution of the body of the method? See, that is nothing but a method, right? I mean, where the name has not been given. So what is an interface? How do we compare it with a normal class or something? Okay, so far we have mostly seen about the class. So how do we compare with a class? Or any questions, yeah, specific questions which you had from any earlier session, yesterday's session specifically? Yeah, any questions? No questions? Okay, fine, then I'll proceed. So yeah, I think we need to be more interactive, but so can you, okay, so yeah, what is an interface? Mainly comparison with a class, because we know about a class, right? You may compare with the abstract class also, because interface like class is also abstract. Okay, interface. Okay, we can say interface is like an abstract class. Okay. Okay, but where are the differences? Okay, let's say which cannot have instance variables, or which can, from variables point of view, it cannot have instance variables and static variables also, other than static variables other than final. And we understand meaning of final. Okay, final means other constants. If a variable, a static variable declared final, so that's the only kind of variable allowed. Okay, yeah. What else? Comparison with the abstract class. Yeah. So what all comparison are there? Yeah. It cannot inherit from a class. Okay. See, a class will inherit from a class by using extents, but interface cannot say I want to inherit from a particular class. Okay. What else? You can say from Java 8 onwards, or prior to Java 8, could only have abstract methods. Can have so methods point of view, only abstract methods. So from Java 8 onwards can have method implementation by using default modifier. Okay, fine. Can have static methods also. Okay. What's the other thing? It's a very simple thing. I'll put it in a word. It looks like this. Okay. Participates in multiple inheritance. Okay. And so that's what we can say. So that's how it is different from a class. Okay. Okay. Fine. We are not looking at generic, but like classes are generic, even classes can be generic, interfaces can be generic. Generic will come back later. Okay. Okay, so this is one thing about interface, right? So we were thinking about something like this. Okay, as an example, fine. Okay. Okay, as an example, what interface we can use? So I was giving example of a ready-made interface which is there in the Java library. Okay. Okay. Example is, what was that example? Comparable of some element type E. Okay. So it is, see, this is what I meant, int binary operator equals, and then int a comma int b. Okay, it could be any variable names you decide, and I have this semicolon within the body. What I have to do is I must have a see, I am saying return a plus b, a very simple thing, return a plus b. So what do you think when I execute this statement, when this statement is getting executed, what does it do? Does it execute the return statement here? Does it execute anything else? Here, this does not result in the execution of this. If you look at this entire thing from here to here, okay, if you look at that lambda expression, a lambda expression is a definition. A lambda expression here is nothing but a definition of a method. It's not the execution of this method. It's only defining a method, but here we are getting an option of keeping the method in a variable called op1. Okay, op1 is referring to an object. op1 is nothing but referring to an object which has a definition of a function. Okay, so this thing results in something like this. This is your OP1. Okay, this is a reference variable OP1 equal to O. What I have done here, I have created, so lambda expression is just creating a function object, and this starts referring here. It's not the execution of the function, but creating an object with the definition like this. Okay, this function is not yet executed. How will this function be executed? If I have to execute this function, I want to execute a plus b. Oh, then invoke that method. How do I invoke that? A plus b. I have to pass two parameters and invoke that method. So for that, what you can do is you can say op1 dot apply as int 7,5. That's going to return an integer value. This is when we call this, that's the time when this gets executed. OP1 is keeping a reference to a function. The lambda expression is the definition of a function. Creating an object, just creating an object, that's it. A lambda expression only creating the object. It's not executing the function which is being defined. Someone will have to invoke that abstract method of the functional interface. This is a functional interface. That abstract method of the functional interface has to be invoked in order to execute that. Okay, so the place where you are using a lambda expression, you are not executing the code of the lambda expression. You are actually defining the code and keeping it in a variable for execution whenever you want, right? Also, you can see that you could have a different, at another place, you could say op1 equals again and give a different lambda expression. So for the same, fine. So it can say, okay, stop referring here and start referring here. You can make op1 equals again another definition. So at a different point of time, that same variable op1, if someone is using dot apply as int again, so at that point of time, whatever function he is having, that's the one which will execute, not the one. So you have a variable which holds a function object, and it can refer to a different function object at a different time. Okay, and it all depends. The use of this function, okay, the use of this function will be when someone invokes the method of the functional interface. That abstract methods of functional interface has to be invoked. So this is when it is getting used. When someone is saying apply as int, because that's a method. Okay, you can note one thing here, that the one who is defining the implementation of the abstract method need not be knowing the method name. When we write a lambda expression, we're actually defining apply as int method. Right? We are saying, oh, this is my implementation of apply as int method. Your lambda expression here is nothing but the definition for the method apply as int, which we are keeping in op1. Fine, is this clear? Okay, I think we'll have to continue tomorrow. Okay, so today, yeah, fine. So what we have decided is we'll just initially let's start with revising the interface. Okay, so we started with this question, what is an interface? And so we make comparison with the abstract class, right? So interface like an abstract class is abstract, right? It is abstract, right? We can't create objects. Yeah. So what are the differences with an abstract class? It cannot have instance and even static variables. Static variables can be there, but then it has to be only final. So from variables point of, from members, what members go in a class or what members go in an interface, right? If you are making that comparison, yes, the fine, for variables the comparison is this. Okay. From inheritance point of view, it cannot say I want to inherit from a class. Abstract class will inherit from a class first, right? Okay. Prior to Java 8 could only have abstract methods, okay, and from Java 8 onwards can have method implementation. When you understand method implementation, that means we are providing the body of the method, right? For an abstract method, we don't give the body of a method. Okay, so from Java 8, yes, it is allowing that you can have non-abstract methods. So then you declare specifically by using the keyword default. Okay, there's a default modifier for methods now. Okay. And from Java 8 onwards can have static methods. So static methods also were not available prior to Java 8. Okay, participates in multiple inheritance, right? We understand that a class could implement multiple interfaces, okay, which is not the case with a class. A class cannot have multiple superclasses, but class can have multiple super interfaces. Yeah. What other difference? Yeah, can list more differences here. Yeah. From the members point of view, it cannot have, okay, and cannot have constructors, cannot have the blocks, okay. Static and non-static blocks, if you recollect. Okay. So those will not be allowed in an interface, right? So I think, yeah. And so this all can be listed as difference from a abstract class. Yeah. Okay, fine. Fine. So let's take example of a interface. Comparable interface is a ready-made interface in the Java library and how it has been used. So the interface just provides one method here, comparable interface. Okay, what is the method in the comparable interface? Okay, I'll just first put the interface here. We have done it earlier, interface, and okay, and within the body of the comparable interface, the method which is provided is, it's a fine. I'm not declaring anything. Therefore, it would be an abstract method. Int. Okay, this is a it is using generic. It's a generic interface. Okay, fine. So if I have a class which is to be non-abstract and it is comparable, see what you could do is, for example, okay, let us try to use okay. Another thing I think we discussed yesterday about the comparable interface, that what is the purpose of comparable interface? The implementation of this method, what is this implementation of compare to method? The idea here would be to define the logic for comparison objects of a class which implements this interface. Okay, so the idea here is that it would be any class which says it has got some kind of a natural ordering, okay, would implement this interface. Okay, so if you are saying so if you're saying that objects of account class have a natural ordering, then account should implement okay, it should implement the comparable interface. And we'll see other use of interface also. There's another kind of interface, and I think we'll go to that particular topic. Okay, so fine. So for example, yes, what should be done? Okay, I think other thing we discussed yesterday was about the compare to method, the value returned by the compare to method. It returns a negative value, a positive value, or a zero, right? And how it would be interpreted. So interpretation of the return value that we have seen yesterday, I think. Right? Okay, so if we are saying account has to be implementing comparable interface, then how do we write that code? Okay, how do we change the account definition? Let's make this change in the account class, and we have the account.java. Okay, so how do we update this and say, oh, I want a comparison logic, right? Okay, so for that, yes, what should be done? We'll say this thing implements comparable. But one thing here, comparable is a generic interface, and therefore whenever we use it, we must specify a type for it. Oh, so comparable. Oh, what is it? This account going to compare with? Object of account will be compared with another account object, right? So we'll say it is for comparing with account. Okay. And so from generics point of view, yes. Later we'll come back to generic, but yes, here we may use generic, okay, to that extent. And so here is class account. We'll say, oh, it implements comparable. I think one thing, one change we haven't done in the account class, we didn't make it abstract earlier. Okay, yeah. Account should have been abstract. You know why? Why would we want account to be abstract? Yeah, why do we declare a class to be abstract? The reason would be because we want that objects of this class cannot directly be created. You must have subclasses for account, right? We have created subclasses for account, right? Okay, like current account, savings account, those are the subclasses. But what we have to now also ensure here is that our test account, okay, fine. The class test account is going to, it shouldn't be allowed to create object of account like this, right? You have to either create a current account or a savings account. Okay, fine. What is getting assigned to AC1, AC2? Creation of account we don't want to allow, right? You don't have just account, right? You will either have a current account or a savings account, and not just only account itself. Okay, so maybe I would like to make it into a current account here. Okay, AC2 equal to new. Maybe you want to have a savings account here. So we can have an account of each of those two types. Again, here, no, you can't say new account, this one also. Okay, so maybe this is again current account, and this would be a. So you don't create account saying, oh, I just want an account object, right? And that is the idea here. Okay, if this is the idea, then what we should do with the account class? We should declare it as abstract. Okay. Okay, now because it is abstract, it is allowed to have abstract methods. Because account class is abstract, account is allowed to have abstract methods, right? But we are still free that we may not have any abstract method. At this moment, account class has an abstract method. Oh, we haven't declared anywhere an abstract method. Does account class have an abstract method at this moment? Yeah, anyone answer? Any idea what is the abstract method in this? Look at this heading, right? If this is what we have declared, right, it is fine, it is implementing comparable. So any abstract method now? Right? It is actually inheriting the abstract method from comparable interface. Okay. So if I have to override, I can override in the account class itself, right? Or you may go back and individually override in the current account and savings account, both the places, right? But better option here would be to override the account, the comparable interface method, so at the rate override. Okay. And this is the method which you would like to actually override. Public in compare to account is. Okay, so this is what is the comparable interface, fine. So overriding method from the comparable interface is going to be like this. Okay, and how do we want to override? We have to return an integer value, right? So compare, see, the ordering here has to be based on the account number. That is what is the ordering for account class, right? The default ordering will be like this. Okay, so we can say return this dot account number. Yeah. Yeah. How do we return this? This dot account number, if it is less than AC dot account number. See, I'm just giving you one way of doing it. Okay. In that case, return a minus one. Someone can put like this. Otherwise, this dot account number greater than AC dot account number. then return a 1. Okay, plus 1 maybe. Otherwise, return a 0. Yeah. And I'll put brackets maybe, I think, to make it more clear. Okay, so this is just one way. Okay, this is one way you might actually override the comparative method, right? It's just about returning a value which is either negative, positive, or 0 based on account number, because our comparison of two accounts is based on their account numbers. Okay, and this is just one way of doing it. Another way this code could have been written. Okay, see, this is because if the account number was a data type in, the code would have been much simpler. Okay, but since it is a long type, we can't say return the difference of the account numbers. If it's an int type, we could have just said, okay, let's return the difference of the account numbers. Okay, fine. One thing you should remember now, okay, which I would like to remind here is, so I'm just giving you the alternate way of doing it. Okay, so instead of returning like this, we could have said return. Okay, now this is yesterday's, some of the things from yesterday which I'm trying to use. We know we have this class called we have the wrapper classes, and all wrapper classes implement comparable interface. Okay, so even the type long is implementing comparable interface. So I can say this dot account number. The type for this is long. Okay, I can convert it into an object. This is primitive type long. I can convert into object by using the casting as long. Okay, so this becomes, from primitive long, it is now an expression of type long. Okay, and this is a comparable interface. I can use dot compare to. Okay, so I'll just use the account numbers, the long data types compare to method. Okay, I can use this also, AC dot account number. So this will be returning whatever the compare to method does in the long data type. Okay, so that's another way of overriding the compare to method. Okay, when is this okay? When implementing the comparable interface, and what is the use of implementing comparable interface? Why do we have to implement the comparable interface? Okay, let me come back to this one. Right, so let's do this, right? Let's try out the sorting of account objects by the account number. Okay, and for this, yes, one of the classes which we have to use in case I did mention about this. We have the class called arrays, right? So there is a arrays class, and arrays class has okay, fine, one of the static methods. So one of the static methods is sort. Okay. And how is that sort method? So within the arrays class, this is the method public static, and then for some type t, okay, return type is void, name of the method is sort, parameter is array. Okay, if you are giving array of some type, okay, then it can sort this array provided the elements in the array are comparable. Okay, if they are not comparable, yes, we'll get an error. Okay, so let's try this out. Okay, fine, let's try the sort method and see the output. Fine, how we can test it out. Okay, so here is the account class. So account class is now comparable, right? And we have the, so we created some 3-4 different objects, and maybe we would like to sort them out by account numbers. Okay, so yeah, how do we do this? We would like to have a array of account. Okay, a variable name called account array equals new. Okay, you want to have an account array of size 5. Okay, fine, we want to have a account array of size 5. In this account array, we can have objects of any type of account. So current account, savings account, anything can be there. Okay, we need to initialize those 5 variables. How do we initialize them? Account array of 0 account array of 0 equals, so you can say, okay, that is AC1. Okay, that's the one which we had created. So we can keep on assigning to all the 5 elements in the, okay, let's see this, right? For 1, for 2, and for 3. Okay, and yeah, for 4 also we would like to have, right? So fine, index positions 0 to 4 because the size is 5. Okay, here it is AC1, here we can have AC2, here it is AC, this is AC3. This we can create another one, new, let's say another current account. Okay, and this can be created with some account number. Okay, okay, so there's an account number, there's some name. Okay, and we can have some initial balance. Okay, fine, so we got initialization of our array. Fine. How do we print the array? So let me put the system.out.println. Okay, so how are we going to print this? We've got the account array, right? How do we print account array? So you can write a for loop. That is one option. But another option which you could use here, let me show it here, by using a method, again another method from the account class, from the arrays class, sorry. I'll just show what it is, right? So let me put the method name here. Okay, so arrays class has only static methods, right? One of the method is this, another method. So we have another static method which is public method returns public static. Return type is string. Okay, name of the method is toString. And takes as parameter an array. So it can take any array as a parameter. Okay, so I think this is generic. It will take as parameter the array. So for an array, yes, it can be converted into a string. So that can be done with the help of arrays.toString. Okay, this will say arrays.sort, and for this one we'll have to say arrays.toString. So for printing purpose, yes, let's put the arrays.toString method. So here in the code we write arrays.toString as something like this. So we can say system.out.println, okay, arrays.toString. We already have toString in the account class, but the array does not have a toString. See, okay, let's do it in 2 steps then. Okay, let's try something like this. Let's try printing the account array directly. Okay, and we'll try printing the account array directly. Fine. Okay, let's just compile and run this code. Try compiling and running this code. That is creation of an array, putting the elements in an array. Fine. We had created 4 elements, 4 objects, and we have put those 4 objects in a array, and 5th one also we have added. Okay, fine. And then we are saying, okay, let's print the account array. Okay, and what do we compile? Test. Sorry, within test we have the test account.java. Oh, there's an error, I think. Okay, see, it can't find account, it can't find current account. What is the reason? You can see the first error message which we have. Account AC1 cannot find symbol account. Class account, no, it can't find. Let's have a look. What's the reason this? What is missing? This is in a different package. The package is test. And so we should have, we may use the import declaration here. Okay, import bank dot, one could use bank dot star that way also, right? Or individual, you could have written bank dot account, bank dot current account, bank dot savings account. Yeah, we have used all 3 of them. Okay, so we can now try again by compiling. Okay, okay, spelling mistake here, and that's on line number 25 in test account. Okay, Fine. So now this is compiling. Okay, and we can try running the code. Oops. And test.test account. Okay, let's try running the code. Fine. So printing account array, look at the last two lines. It says printing account array, and then it gives out square bracket L. Fine. And there it is saying bank.account semicolon. So this is nothing but equivalent of saying get class dot get name for the type account array. It's an array type, and therefore you get a symbol like this at the rate and the hash code value. It is trying to convert the array into a string, and this is how it will be converted into a string. So that's the reason why it may be a better idea to use the toString method, fine, which is available in the arrays class. So here, instead of directly printing an array, you can now use arrays.toString and use this as a parameter. Okay, give the array as a parameter so that each element in the array will be fine. It will print the elements in the array. So array conversion will be in square bracket each individual element separated by comma. Okay, let's see the output now with this. Okay, let's compile. Oh, arrays class. We haven't used the import for the arrays class, and we'll need another import. Okay, so we are using the arrays class from the java.util package, and we compile it, and now it has compiled. And if we run, okay, you can see how it's coming. Each individual element, okay, separated by comma. So in square bracket it says current account colon account number name and balance. That's for the first one. Okay, comma, and then the savings account. See, it's giving the name of the class colon and account number name and balance, right? So yeah, it has created these account objects. Fine. We want them to be in order. Currently they are not in any order. They're not ordered by the account number. Okay, we would like to have them ordered. So we want to have them ordered. Yes, what we should do? How do we order them? Arrays dot sort. Parameter is account array. Okay, I'll just copy these two lines and modify them. Okay, so we just print it again. We have compiled, and if we run, then at the end you can see after sorting, yes, it is ordered by the account numbers now. When we can see this output which is coming, that it is now getting ordered by the account number. Okay, so fine, this is what is the use of comparable interface. See, if I didn't implement comparable, let's make that change temporarily. Fine, let's go back and say, oh, I'm not going to implement the comparable interface. Okay, so if my account class doesn't say that it is implementing comparable, you may have put that method, right? But it doesn't say that it implements comparable. Okay, so something like this maybe. Right? So I'm saying, okay, it's a, one second, what happened? Okay, it's here. Yeah. It got closed, I think. Yeah. Okay, so suppose we are having it like this. Okay, that is, if we are not saying that it implements the comparable of account. Okay, if you don't put it, and let's try compiling and running the code. Okay, fine. What about compilation? Any problems with compilation? What do you expect? Will it give a compilation error? Okay, want to see the code? Is there a compilation error? Since it is not implementing the comparable interface, and putting an @ override here is an error. It will complain here that this is not comparable. And it's not an overriding method. That's one thing. Okay, so we want to keep the method, but we don't want to say that it is comparable. We want to have that method, but maybe we don't want to say that this is comparable. And let's try this now. Okay, I want to get that error. Fine, just check this error. It should say there's an error. @ override, that's an error, right? Okay, so we don't want to put it as a overriding method and say, okay, I have a method called comparator, though I'm not implementing the interface, so I'm not of a comparable type. My type is not comparable, and a very simple account object. Okay, fine. I'm not saying I'm going to be comparable. I mean, account doesn't say that it is comparable type. Since it is not declaring itself to be a comparable type, okay, fine, let's compile again. Oh, this is compiling, but when we run this code, see, the place where we try to do the sorting, fine, here, exception in class main, Java, fine, class cast exception, fine, and where is the exception? So you can read the exception, how it is coming, class cast exception, okay. The savings account cannot be converted to class java.lang.comparable, okay. Okay. So the last line which you can read here, okay, this one at this place, okay, fine. This is where it says line number 36. Okay, this is at line 36 that there is a error at